I get so excited with all these easy lessons. I hope you are as excited as I am. So let's go ahead and copy down the essential questions. How can you use transformations to show that two figures are congruent? Well, let me just go ahead and answer the question right now. We talked about two kinds of transformations. We talked about rigid and non-rigid. So if you remember, with the non-rigid transformation, we talked about how the size changes, but the shape stays the same. And in order to do that, we have to do what's called a dilation, which means we gotta multiply the x and the y by the same number, okay? So then those are what we called similar, okay? So we're not talking about this part. Okay, I think as a matter of fact, you're going to learn about that when you next year when you go to Math 2, because I'm teaching that in my Math 2 class right now. But for you, you're only looking at the rigid transformation, because this one, if you remember, I said is the same shape and it's also the same size. And so that's the only thing that you have to know. So how can you use transformations to show that two figures are congruent? Basically, if they either, I want to write down here, but there's writing, so I'm going to write here. So if basically you rotate it, or you reflect it, or you translate it, or maybe you did a mixture of all three, or two or whatever, and you see that the shape is can be mapped exactly onto itself, we know that the two figures are congruent or the same. So we can only use rigid transformations, okay? And when we do that, we know that they have the same shape and the same size, and of course that's why they're congruent to each other. And pretty much that is the whole lesson. And so I'm not gonna go over all of this because you can do this on your own. It's super easy. And what I'm gonna do is I'm gonna go straight into your homework question, because that is all they're asking you. Okay? So this is your very first homework question, your turn questions that I expect you to do. It says use the definition of congruence to decide whether the two figures are congruent. Again, we just talked about this. We can only use rigid motions, and of course that is part of our title right here. Okay? And so complete the explanation. So it says use the definition of congruence. Okay, so we gotta figure out if this is congruent or not. So you know what, let me think. If I were to draw a line right here, I think this is going to be like a reflection. So let me see if that's going to work or not. So what I'm gonna do is I'm going to draw a line like starting from here and go like up to here. So if I had a line like right here and I were to reflect this shape over to that side, do you think that will work? Because we just talked about reflections in the classroom, right? So this is half or 1, and this is 1. And distance from here to here is 2, 4, 5, and this is 2, 4, 5. And then distance from here to this line is 2, 4, 6, 7. Distance from here to that line is 2, 4, 6, 7. Hey, guess what? This is an exact reflection of this line right here. Okay, so let's see. You can map JKL, that would be this shape over here, to that shape with a reflection, but it doesn't say you could reflect across the line that I drew, right? So I have to pick y-axis or x-axis. So in this case, it would be y-axis because I have to reflect across that line. So let's just go ahead and stop and draw this really fast, because if I were to reflect across the y-axis, then the distance from here to the y-axis is 1, 2. So then I would have to go 2 more. Distance from, 2, 4, okay? So I would have to go 4. And then over here, this is a negative 10, so I have to find positive 10. This one is a negative 8, so I'll have to find positive 8, and there you go. This is a reflection across the y-axis. And then after that, obviously, I'm going to have to move it over to 4, 6 to the left, right? So I'm just showing you how this is done. followed by a horizontal translation. Horizontal because we're going left or right. So the figures are congruent. The coordinate notation for reflection is, remember we talked about this in class, the rule for a reflection is x comma y becomes, when we reflect across the y-axis, the y stays the same, but only the symbol for the x changes, right? And the coordinate notation for the translation is we had to move to the left by 6. So it's x minus 6 and y stays the same. So as you can see, you might think that this is a very difficult question, but if you paid attention in class yesterday, this is actually a very easy question. And I don't know. I'm going to ask you, what do you think? Should I give this question to you on paper or online? So this is something that you can tell me in class if you have watched the video. So now let's move on to the next question, which is not really letting me do. Okay, so the next question is this one. Of course, they're congruent to each other. It's very obvious because you see this x-axis over here. You can see that if you just flip it over, is exactly the same. So this is a reflection across the x-axis. So this is an easier question. So the figure is congruent because, again, a reflection is a rigid transformation. And so across the x-axis means x stays the same but y changes, right? So click on check answer. And then it says it's correct. So I just wanted you to know how easy it is. And then the next section now makes you do more than one move to get to the next one. But it's all gonna be the same, okay? Congruent means you are using reflections, rotations, and translations to map to the other side, okay? So now we have two shapes, and it's really cool because now they're not asking us, is it congruent? No, they're saying it is congruent. Okay, but this time they want us to find out how we moved from this, how we moved from here to there. They are the same, they're telling us, okay, but what did you have to do? What kind of rigid motion? So did you do a translation? Did you do a reflection? Or did you do a rotation? Or did you do a combination of more than one thing? That is pretty much what this question is asking you. Okay, so don't forget we're using this and then we have to go there. So let's go ahead and use our brain a little bit. Okay, it helps us over here because it gives you the answer. Okay, so we're going from here to here, and how do we know that? Because it says so right here. You're going from A, B, C, D, E all the way to P, Q, R, S, T, from here to there. So you can map A, B, C, D, E to P, Q, R, S, T with a reflection across the, oh wow, they're already giving us a hint. So then it's not like you gotta figure out so much stuff, right? Okay, so initially you're looking at the shape up here and then another shape down here. So you might be like, oh, reflection across this line, the x-axis. But if you think carefully, that doesn't really work, okay? So you know what? Let's try a reflection across the y-axis. That would be this line right here. So if my line of reflection is going to be this line over here, let's see what's going to happen, okay? This point D is 2 units away, so go 2 more over here. This unit E is like 1, 3 away, so there you go, I put it there. And this point is 1, 3, 5 away, so 2, 4, 5. This point is only 1 unit away, so put a point there. This is 1, 3, so 2, 3. There you go. So I just reflected it across the y-axis. Oh, so then once you reflect across the y-axis, what do you notice? These two are exactly the same. I just have to bring it down. But how many do I have to bring it down by? This is 1, this is 2, so that's 3, and then 5, 7, 9, and then 1 more, so it's 10. So if I want to bring it down by 10, x is the same, but y is going to be y minus 10, and that's going to be the rule that goes in here. So the coordinate notation for the, so the coordinate notation for the translation is this one. So that's the answer for this section. And the coordinate notation for the reflection is x comma y becomes what? If we reflect across the y-axis, then the y stays the same, but the x switches symbols, okay? So let's go ahead and plug those in. Now, it was easy for me to do it like this, but for you, you might be thinking, oh, we might have to reflect across the, what is this? X-axis first, but when you try that, you'll figure out that it doesn't match. So I'm thinking that this is a good question to give you on paper. So anyhow, let's go ahead and fill out the answer. Reflection across the y-axis, so the rule is negative x, and then x minus 10 because you had to bring it down. So you check your answer. Oh no, what have I done wrong? Oh, I had to bring it down, so it's y minus 10. X stays the same. And did I explain it wrong earlier? Okay, so x stays the same and we brought it down, so it's supposed to be y minus 10, okay? Check answer, and that is correct. So now we're gonna move on to the very last question. There is another section with the homework, but that part is, I think, kind of silly, so I'm just gonna have you do up to these questions over here, okay? So anyhow, the figures shown are congruent. Find the sequence of rigid motion. So we're going from JKLM, which is this one, the top one, to the bottom one. So let's just kind of try and use common sense, but also cheat by looking down here. It looks to me like a reflection across the x-axis, don't you think? And then you have to like move it. So you know what? I'm gonna try and move it along this, and then let's see. So this is 2 units away, so go 2 more. 2 units away, go 2 more. 2, 4 units away, oh no, 2, 4, 6 units away, so 2, 4, 6 units away. So this one is 2, 4, 6, so 2, 4, 6. There you go. So now I'm going to connect the points, and that is a reflection across what? The x-axis. So then obviously from here, I think these two are exactly the same. I gotta go down by 2, no, go down by 2, 3, and then 2. So I said down 2, and then left 3, right? So let's remember that. You can map JKLML to WXYZ with a reflection across what? This was the x-axis. Followed by a translation, the coordinate notation for the reflection is, if you reflect across x-axis, x comma y becomes x is the same, but y changes symbol. And the coordinate notation for the translation is down 2, left 3, so x comma y becomes what? X minus 3, because you do the left side first. And then I'm not supposed to close my parentheses. Comma. And then down 2, so that's y minus 2. Okay, so let's go ahead and fill this in. X-axis, so y changes, and then I said it was left 2, down 3. I hope that was right. Yay, good job. Okay, so we're done. If you move on, there is more concepts that they try and explain to you. And of course, I want you to study this, but when you see your turn questions again, I don't know why, but these questions are, it will be easier if you actually solve them like by using angle, like using a protractor, and that is not really good. So you don't have to worry about this, okay? So when you go into your evaluate section, I want you to work on all the questions, but you can go ahead and stop at question number, yep, you can go ahead and stop at, wait, 24. Yeah, you can go ahead and stop at 24. So starting from 25 and all of them, just don't worry about it, okay? So those are the only things you have to worry about. Well, I hope you had fun learning today. When you come to class, I'm going to try and teach you a little bit, but mostly you're just going to go to the boards, and if you need graph paper, I'll provide half sheets for you, and I will try my best to help you a little bit, but you know, by now you should be able to get it, and you should be working on the evaluate questions, okay? Happy learning. Goodbye.